Hey guys, I apologize for the issues with the sound. I'm not really sure what's going on. I know a few teachers are having trouble. So what I'm going to do is I'm just picking out questions that I did today in class and just making another video, and hopefully you'll understand it. I picked out the harder questions. So if you go onto Google Classroom, you will see that I scanned the answer key for the classwork yesterday, which is page 1 and 2, the homework last night, which is page 3 and 5. And then today we were working on pages 6 through 9. So I'm kind of a little all over the map because I wanted to do a little bit of review. So I'm looking on page 3 at number 3. And this is one of the harder questions. So this is one that we did in class. So what I said to you yesterday, and I repeat it again today, is when you're trying to choose your U, usually you look for something that's in parentheses, which we don't have, underneath the square root, which we do have, in the denominator, which we do have, and we try to pick the biggest exponent that we can, the highest exponent that we can, usually for our u. All right, so then that all being said, I'm going to pick for my u, I am going to pick x cubed plus 3. Okay, then that would mean that my du is going to be, equals 3x squared. Let's make that look like an x. It does not look like an x. Dx. All right, so the issue that we were having is if we look at this right here, that we need to make look like a 3x squared as opposed to a 2x squared. So what I was saying today in class was, basically what you need to do is you need to multiply that 3 by some number and get it. Actually, wait a second. I think I just need to switch what I just said. So hold on one second. So what I need to do is I need to multiply this 2 up there by some number, and I need it to equal 3. So this number here would be, if I just divide both sides by that 2, you can see what goes in that box. Okay, so that would be 3/2 or 1.5. I'm sticking with 3/2 though. So then what I need up here, and let me just kind of point to this. What I need then up here is I need to multiply this by 3/2 because that will make this a 3. So if I need a 3/2 here, that means I need a 2/3 here, correct? Okay, so then I'm going to do 2/3 times the integral, and then we're going to have du over the square root of u. Okay, now so let's look at that because I don't want to leave that like that. So I'm going to go one step further. I'm going to keep that 2/3 there, 2/3 times the integral of, and I'm going to make that u to the negative 1/2 power. Makes it a little bit easier to integrate. So let's bring down that 2/3. And then if I integrate u to the negative 1/2, that becomes u to the positive 1/2. And then technically divide by 1/2, but I like to multiply by the reciprocal, which would be 2. And don't forget, we have plus c. Okay, so now all we're going to do is we're going to multiply through this 2/3, and that's going to be 4/3. U to the 1/2. Now remember, u to the 1/2 is really just radical, right? So that's going to be radical u plus c, because remember also, even though 2/3 times c is a constant, and it is a different constant, it's still a constant. So we just represent it as plus c. Okay, last step. So now all we're going to do is we're going to substitute back in our u value, which is x cubed plus 3 plus c. And there is our answer. Okay, and that answer is choice E. All right, so now I am looking at number 11, and number 11 is on page 6. So if you want to turn to page 6 in your notes packet, okay, and we're going to look at number 11. This was one that we did in class today. So you have a video of it, you just don't have me talking you through it. All right. So what I was saying about this one is this one's a little tricky. I don't know that I would really use U substitution. What I was trying to show is that you actually don't need to. So let me just rewrite this, 3 ln of x dx. Okay, what I'm hoping that you remember is that when you have a number in front of any kind of e or ln, that's the power rule. So what I was saying in class today was if you saw addition with e's and ln's, hopefully you would remember that you're supposed to multiply. And if you see subtraction with e's and ln's, hopefully you would know that you need to divide. So the same thing happens here, where when we have a number in front, and you should have done this in Algebra 2 as well as pre-calc, that means that this 3 really was right here at the end as an exponent. So I would like to just rewrite this, and the way I'm going to rewrite this is e to the ln of x cubed. Okay, and there's a reason why I'm doing this, because one more thing that we need to go over, and then I think you'll see it. Remember that an e and an ln are inverses of each other, so don't these guys cancel each other out? Okay, so that's why I was moving that 3 all the way in the beginning in the first step there. So then what happens is these guys disappear. So really all I'm doing is I'm integrating x cubed. And that's why I was saying it's a lot easier to just do that, because if I integrate that, right, that's going to be x to the 4th, technically over 4. I'm going to write times 1/4 plus c. Right, and that would be choice D. Okay, so I also said in the video, which of course you couldn't hear, cross off number 12 and cross off number 14. Okay, some of them are repeats and some of them I don't want you doing. So I want to look at number 13. Now 13 is similar to number 11, where we really don't need to do U substitution. There's an easier way to do this. So in this case, try to remember that this x to the 4th is the denominator for 4x cubed, and it's also the denominator for -2. So I'm going to split this integral up into 2 separate fractions. So I'm going to write it as the integral of 4x cubed over x to the 4th, and then minus, because there's a minus sign there, integral of 2 over x to the 4th. Okay, and then integrate each of those separately. All right, so now this one on the left-hand side, I'm going to simplify that a little bit, and that's going to be the integral of 4 over x dx, and then minus, and this I am going to make that 2x to the -4th dx. Okay, so let's look over on the left-hand side, because this is still maybe a little bit tricky. So here, do you see this is kind of dx over x? Like this dx here, I could have it up here. So this is dx over x, and hopefully you realize dx over x is like du over u, which is ln. But we have this 4 in the way. But remember I said to you that whenever you have constants, you can always pull them out of an integral. So that's what I'm going to do. So I'm going to write this as 4 times the integral of dx over x. And then I know that from there, I'm going to have that 4, right? And then dx over x, when I integrate that, is the ln of x. Okay, now technically, when I integrate and get ln, this is absolute value. I'm not going to worry about it so much, but it is in the answer choice, or one of the answer choices is in choice C, which actually is not the answer. But if you write it, fine. If you don't, fine. For now, anyway. When we get to some of the AP questions, I'll go into it in more detail. All right, so then let's just keep going here. So then this is going to be minus, and then I'm going to have 2x to the -3rd power, right? And technically over -3. Oops, -3. And then don't forget plus c. All right, well, these double negatives make a positive, right? So now I just want to also point out, let me go back here. Remember when I have a number in front of an ln or a log, that starts out as a power. So this is really just ln of x to the fourth. Hint, hint, hint. Okay, so that being the case, this is going to be ln of x to the fourth. Double negative there makes that positive. And then we have 2/3. However, that x to the negative third, I'm bringing it down to the denominator to make it positive, plus c, and there's your answer, choice B. Okay, now I am on page 7, and I said to cross off number 16, because it's just the same exact as the one that we just did. And when you get to page 8 and 9, which you're finishing for homework, on page 8, you're going to cross off number 8. We're not doing that. And then everything else is good. Okay, so the last one that I'm going to do is I'm going to look at page 7, number 17. So a lot of kids initially, and I just want you to, I want to show you this, and I wouldn't write it down. Initially, they were saying, okay, you should be like e to the sine of 2x. Now, here comes the issue with that, though. So if that's the case, then that would mean that this would be my u, right? So then to find du, I would take the derivative, which is e to the u du, and the derivative of sine 2x is 2 cosine, oh, I'm not going to be able to fit it in here, 2x. Now, do you see that let me point this out to you, my derivative has a 2 cosine 2x, which I don't have here-ish, and it also has another e there, which I don't have another e here. Remember I told you when you're doing u substitution, you can only multiply by a constant term. You can't add on an entire e to the sine of 2x. So when that happens, what that usually means is you took too much for your u, and you should kind of pare it down a little bit and take less. All right, so I am going to then, oops, got my pointer on there, sorry. I am going to make my u sine of 2x. Okay, I'm going to tell you, not all the time, but most of the time, your u will not involve an e. Okay, don't quote me on it, but most of the time it doesn't. All right, so now derivative of sine, we know is cosine, right? So we've got cosine 2x, but then we have to take the derivative of that 2x, which is a 2, and dx. All right, don't panic. So let's look at this piece right here. Do you see that that is e to the u? Okay, because this right here is your u. So this is e to the u. All right, now let's talk about this piece right here. And actually, I probably shouldn't have circled that dx there. So let me put this in a different color. So let's look at this part right here. That says dx over secant of 2x. Well, I don't have secant here, do I? But aren't cosine and secant reciprocal trig functions? So if you want to think about this in another way, look at it like this. If I put a 1 here, which I can, right? Isn't that really cosine? 1 over secant, isn't that cosine? And isn't that what we have right here? So another way to write this really is just cosine of 2x dx, because what I circled right here is really cosine of 2x. And then this is my dx. So compare this and compare this and look at what's missing. Just a 2, right? So all I need to do is multiply this by a 2, which means I'm going to need a 1/2 on the outside. okay? All right, mull that over. So, like I said, I'm going to need to multiply by a 2 on the inside and a 1/2 on the outside. And then I'm going to have e to the u du. All right, well, let's go ahead and integrate. So that's going to be 1/2 e to the u plus c. How easy is that? Now, the beginning part was hard, but all right. So then we have e to the u power, which is sine of 2x, and then plus c. And there's your answer.